some examples. You have to solve some problems in an examination. I'll be giving you 4 examples now to solve some problems in an examination. Maybe you come across any question that are related like that. So if you have to solve the following, let's say find the following, find the value of the following. A. If you have to find the value of 4 raised to power minus 3 over 2. B. If you have to find 64 raised to power minus 2 over 3. Then D. If you have to find the value of 0.125 raised to power minus 1 over 3. D. If you have to find the value of 14 raised to power 0. Now the solution. The first question now, you have to find the value of 4 raised to power minus 3 over 2. So we say 4 raised to power minus 3 over 2. Now, as I've said in the last concept, I said if we have negative fractional index, we based on the what? On the denominator of the fractional index, which is 2. Look at 2 here now is the what? Is the denominator, and 2 implies square root. So now we say, and as we have known that this power as minus sign here means 1 over, so we say 1 over 4 raised to power 3 over 2. That's the first one. The next one, to turn this what? This square here, this over 2 here to what? To square root by saying 1 over 4, 1 over square root of 4 raised to power what? Raised to power 3. Now we split by saying 1 over square root of 4 times square root of 4 times square root of 4. So we say 1 over square root of 4 here is what? Is 2. Square root of 4 here is also what? 2. Here also is also what? 2. So answer is what? 1 over 8. Or we say 8 raised to power minus 1. That's the first question. The second question now that says 64 raised to power minus 2 over 3. Now I said we based on the what? On the denominator. So this 3 here implies cube root by saying the cube root of 64 raised to power 2. No, before we change this minus sign as power here to what? To 1 over. So we say 1 over cube root of 64 raised to power 2. So now we say 1 over, we split this cube root because this is cube root of 64 times cube root of what? 64. So we say 1 over, what's the cube root of 64? 3 same number that will multiply each one another that will give us 64 is 4. That's 4 times 4 times 4 will give us 64. 4 times 4 is 16. 16 times 4 is 64. So the cube root of 64 here now we say cube root of what? 4 raised to power 3 times cube root of 4 raised to power 3. As I've said, lots of indices. The square root here, this cube here will cancel this cube root here. This one here will cancel this one here. So it becomes 1 over 4 times 4, which is what? 1 over 16. Or we say 16 raised to power minus 1. As I've said, this minus here as power means 1 over. That's the second one. And the third one also that says 0.125 raised to power minus 1 over 3. As I've said, this minus as power here means 1 over, so it becomes 1 over 0.125 raised to power 1 over 3. So we now say what? 1 over, now I said this 3 here as denominator means what? Cube root. So you say the cube root of what? 0.125. You can see it's not possible to find the cube root of 0.125. So we need to turn this one to fraction by saying 1 over the cube root of what? 125 over 1000. Yes, if you have to convert decimal number to what? To fraction. Example, you say 0.125 now. You can say 125 over what? Over 1000. If you divide this, you are going to get this back. The first method we say we move the decimal point backward by saying 1, 2, 3. So it is 3 times. So we say over what? Over 1000. So we now say it as what? 1 over. Then we split the what? The cube by saying cube root of what? 125 over the cube root of what? 1000. We have to divide it sign here, divided here, divided here. So let's turn it and say 1 divided by cube root of 125 over the cube root of what? 1000. This is a fraction, this is not a fraction. Let's make it over 1. So we say 1 over 1. Then this divided to times it will be what? Times. Then this one will go up by saying cube root of what? 1000 over what? The cube root of what? 125. So 1 times what? Cube root of 1000 means what? 3 same number that give us 1000. That's 10. By saying 1 times what? The cube root of 10 raised power 3. 10 raised power 3 is 10 times 10 times 10. Over 1 times what? This one also. Cube root of what? 5. That's 5 times 5 times 5. So as I've said, raised power 3. So cube root will cancel cube. Cube root will cancel cube. So it becomes what? 10 over 5. Which is, if we should reduce it, 5 here 1, 5 here 2. So our final answer here is what? Is 2. That's what? The third one. Then the last one that says 14 raised power 0. As I've said, any number raised power 0 will give us what? 1. So 14 raised power 0. So if you have to solve each of the following equations now, if you are given a question, if you are given different questions like this, you have to solve each of the following equations. So the first question it says what? 1 over 2 raised power x equals to 8. Second question says 3 bracket 3 raised power x equals to 7. The third one 0.25 in bracket raised power x plus 1 equals 16. The fourth one 3 raised power x equals to 1 over 81. Then the last question says 10 raised power minus x equals to 0.000001. You have to solve for x in the following. The first question now, let's proceed. First question says find x when we have 1 over 2 all raised power x equals to 8. We apply laws of indices in all of the following. In this first one now, 1 over 2, you can see now as I've said, anything raised power what? Minus means what? Let's say if you have 2 raised power minus 1, you know this what? 1 over 2. So it means this 1 over 2 here can be turned to what? 2 raised power what? Raised power minus 1. This which means what? 2 raised power minus 1 in bracket x raised power x then equals to what? 8. So law of indices, you can multiply the what? The power together by saying 2 raised power minus 1 times x will give us what? Minus x equals to. Then if I this 8 now, let's find the what? The index of 8. Index of 8 is what? 2 in what? As 8 equals to what? 2 times 2 times 2. You can see 8 is what? 2 times 2 times 2, which means what? 2 raised power 3. So we are using 2 raised power 3 to make what? To make these two bases equal by saying 2 raised power 3. Look at the two bases now. They are what? Both equal. And when they are equal, so they can what? Terminate each other. So these two now can terminate this. So it remains minus x equals to what? 3. By saying minus x equals to 3. Then we are looking for x. X must be the what? Solve the formula by saying x must be equal to something, not minus x equals something. So divide both sides by what? By minus. By saying divided by minus, divided by what? Minus. Or by minus 1. By minus 1, by minus 1. So this cancels this now. So our x now equals to what? Minus 3. That's the first one. So our x is what? It's minus 3. Second one that says solve for x if you have 3 bracket 3 all raised power what? X equals to what? 27. As you can see, we apply law of indices here also. You make the 27 as an index form, as you make 8 in an index form. So let's first say 3 times what? 3 times 3 raised power what? Raised power x. You can say 3 raised power 1 is 3 times 3 raised power what? X. Then equals to 1. Then 27 as an index form becomes equals to 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is what? 27. So in index form becomes what? 3 raised power 3. So 3 raised power 3 is what we are going to use here now by saying 27 turned to what? 3 raised power 3. So they are all in what? In the same base now. So we apply first law of indices here that says times change to plus. Pick one of the 3 and say 1 plus x. The plus power here, as you know, it is 1. This here x. Then equals to what? 3 raised power 3. So we have two same words, two same base now in what? In different state by saying minus 3 cancel what? Minus 3. So now we say our answer is 1 plus x equals to what? 3. So let's collect like 10 by saying our x is equals to what? 3 minus 1. So our x is equals to 2. That's the second question. The third question that says 0.25 all raised to power x plus 1 equals to 16. 0.25 all raised to power x plus 1 equals 16. So look at this as this one number. We're going to fraction by saying 25 over 100. I think I've explained that we move this point twice, 1, 2. So it becomes over 100. So 25 over what? 100. In place value, if it is just once, that's tenths over 10. But it is twice, as hundreds in place value. So it becomes 25 over 100. All raised to power what? X plus 1 equals to 16. So at this point now, we can what? We can reduce 25 and 10 into some number that the power will be the what? If the power can be for both of them by saying if 25 is being reduced into 2 by saying 5 times 5. Then 10 also as index form becomes 10 times 10. Or raised to power x plus 1 equals to 16. 5 times 5 implies 5 raised to power 2. 10 times 10 implies 10 raised to power 2. Then all raised to power x plus 1 equals to 16. 2 is the power of 5 here. 2 is the power of 10 here. So you can bring it out and say, according to the law of indices, 5 over 10 or raised to power 2. Then in brackets, x plus 1 equals to 16. So at this point now, we can say, that 5 over 2 can be cut. We say 5 here 1, 5 here 2. So it becomes 1 over 2 all raised to power what? 2. Then in bracket, we say what? X plus 1 equals to 16. So at this point now, we can before we multiply the power together, let's not have said this side. 1 over 2 can be what? 2 is power minus 2 is power minus 1. It becomes 2 is power minus 1 in bracket 2 is power 2 or in bracket 3 is power x plus 1 equals to then 16. The index of 16 is 2 is power 4 because 2 times 2 times 2 times 2 is 16. That's 16 is equals to 2 times 2 times 2 times 2. That's 2 raised to power 4. So it becomes 2 raised to power 4. The reason why we call it 16 2 raised to power 4 because we see that the final base here is 2. After we've reduced the 25 power 100 into what? To 1 over 2 all raised to power 2. So it has become 2 raised to minus 1 in bracket raised to power 2. All in bracket plus 1 equals 2 raised to power 4. So at this point now, before we cut, let's multiply the power together by saying 2 raised to power minus 1 times 3 equals what? Minus 2. Minus 2. Bracket x plus 1 equals to 2 raised to power what? 4. So at this point now, let's multiply here also. Minus 2 times x equals what? Minus 2x. Minus 2 times 1 will equal what? Minus 2 equals to 2 raised to power what? 4. So 2 can cancel 2 at this point now by saying minus 2x minus 2 equals 4. We are looking for x. So now minus 2x. A minus 2 go for this because they are like terms. It becomes what? 4 plus 2. So minus 2x equals to what? 6. To make this s at the last what? Solve the formula. You divide this by what? By minus 2. Minus 2. Minus 2. Minus cancel minus 2 cancel 2. So it means x. So our x now equals to what? 2 here 1, 2x, 3 and 6, 3. So minus 3. That's what? The third one. And the fourth one now, that says 3 raised to power x equals to 1 over 81. We are also looking for what? Looking for the power x here now. I will look for the power x, as I've said. Look at 1 over 81. As we come 1 over 2 to 2 is power minus 2 is power minus 1. So you can also turn 1 over 81 as what? 1 over 81 is also 81 is power what? Minus 1. It's the same thing. I said this minus means 1 over. So 81 is under. The power 1 is up here, but we don't have 1 here. So now it becomes what? 3 raised to power x equals to, this one becomes what? As I've said on that side, 81 raised to the power minus 1. So now, look at this base here is 3. The base here is not 3. Let's make this 81 as base 3 in index form. So 81 in base can be done to what? 3 times 3 times 3 times 3. Because 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So that's 3 raised to the power what? 3 raised to the power 4. So in index form now, 81 has gone to what? 3 raised to the power x equals to what? 3 raised to the power what? 4. All in bracket raised to the power minus 1. So we say 3 raised to the power x now equals to what? Multiply the what? The power together by saying 3 raised to the power what? Minus 4. So at this point now we have the same base. So minus 3 can cancel 3 can cancel 3 now. So it becomes x equals to what? Minus 4. That's the final answer for the what? The third one. And for the fourth one rather. Then for the fifth one now, that says, the fifth one says 10 raised to the power minus x equals to 0.000001. You can see the standard form. So it means we need to turn this to standard form by saying 10 raised to the power minus x equals to what? If I turn this to standard form, we move it to what? To the significant figure 1. How many times? 1, 2, 3, 4, 5, 6. So it becomes 1 times 6 raised to the power what? Raised to the power minus 1 times 10 raised to the power minus what? Minus 6, because we move it what? 6 times backwardly. So 1 times 10 raised to the power minus 6. So it becomes 10 raised to the power minus x equals to what? 10 raised to the power minus 6. Now they have the same what? The same base. Minus 10 cancel what? 10. Then it remains what? Minus x equals to minus 6. Minus cancel minus. So our x now is equals to. Exponential equation can be reduced to quadratic forms now. This is the next part now. Whereas some exponential equations can be reduced to quadratic what? Quadratic forms. That is, we can apply laws of indices in some quadratic equations. Look at this question. You have to solve for the following exponential equations. Look at, we have 5 raised to the power 2x minus 26 bracket 5 raised to the power x close bracket plus 25 equals 0. Second question, 2 raised to the power x plus 2 raised to the power x plus 1 minus 8 equals 0. For the first question now, we apply laws of indices now. So now the solution now for the first question now. So for the first question now, we say 5 raised to the power 2x minus 26 bracket 5 raised to the power x plus 25 equals 0. This 5 raised to the power x now, we can split, because we have 5 raised to the power x here. And at this point here, we can also make what? 5 raised to the power 2x. When we separate it into 2, we can give what 5 raised to the power x also by saying 5 raised to the power 2 times x, then minus 26 bracket 5 raised to the power x plus 25 equals 0. So at this point here now, we can say 5 raised to the power x, then in bracket 2. It's the same thing. We multiply the power together to give us 2x back. Then minus 26 bracket 5 raised to the power x close bracket plus what? 25 equals 0. So at this point now, we have what? Like base. Like term base. We can 5 raised to the power x, 5 raised to the power x. So you can say, let 5 raised to the power x equals to what? Y. To make it a what? A quadratic what? Towards an exponential equation. So at this point now, we say what? 5 raised to the power x equals y. So here we say y raised to the power 2. Since we said 5 raised to the power x now is now y, then minus 26, then it will be what? Y, 26y, then plus what? 25, then equals 0. So this is what? This is what? An exponential equation. Now, let's find what? The factor of 25. We multiply the same number that will give us 25, and that same number, when we add it or when we subtract it, to give us what? Minus 26 now. So 25, let's say 25 times 1 will give us what? 25. If we should add 25 plus 1, 25 plus 1 is what? 26. And we are going to find what? Minus 26. So you can say minus 25 times minus 1 will give us what? 25. Then we say minus 25 us what? 25. So at this point, so say what? Plus 25 equals 0. So now we can separate. Then here we also say what? This. Then what's common here? Y. Then minus what? 5. Or 25 rather. Then minus, what's also common here? 1. 1 is common here. 1. Then y. Then this one becomes what? Minus 25. Then equals 0. You can't say plus. We should say plus. If we multiply it back, it will give us minus. So we say minus. So we say minus y times minus 1 times y will give us minus y. Minus 1 times minus 25 will give us plus 25. That is why this plus here came to us minus. So at this point now we say y minus 1. Then y minus 25 equals 0. So when we split it, it becomes y minus 1 equals 0, comma, y minus 5 equals 0. Then this one becomes what? Y equals to 1. Then at here, y equals to what? 25. Then for the next question, that's number 2 question, that says 2 raised to power 2x plus 2 raised to power x plus 1 minus 8 equals 0. We can see we have 2 raised to power x, 2 raised to power what? 2 raised to power x plus 1. Here we have 2 raised to power 2x. We can split this as we have splitted this. The same way. 2 raised to power 2 times x plus, this one is plus. So you can't say 2 raised to power x plus 1 is not equal to 2 raised to power x times 1. No, it's wrong. So you can say 2 raised to power what? X times 2 raised to power 1. You can see this law of indices, first law of indices. If we should use first law of indices, this one backwardly to give us this back. And you pick one of the two, say 2 raised to power x times 3 raised to power 1. So you pick one of the two and say x plus 1. So that gives me this back. So this first law of indices. So I don't want this number here to back to what? First law of indices. Then minus, then 8. You can say everything is in base 2. So you can say 2 raised to power 3. You know that what? 2 raised to power 3 is 8. That is 2 times 2 times 2. Then all equals to what? 0. So at this point now we have 2 raised to power x. So I use 2 raised to power x as the what? As the missing number. So let's say this one becomes 2 raised to power x, all bracket 2, to give us the same thing back, x times 2x. Then plus this one also, 2 raised to power x, then what? Times 2 raised to power 1, then minus what? 2 raised to power 3, then equals 0. So at this point now we have what? 2 like terms that are what? That are the same. 2 raised to power x, 2 raised to power x. So now say let 2 raised to power x equals to what? You can use any letter. We can use what? X. Let 2 raised to power x. Let's don't use x. Let's use y. 2 raised to power x equals y. By saying what? Anytime you 2 raised to power x equals what? Y. So y raised to power 2 plus y times 2. That's 2y. This one becomes y. Then y times 2 will give us 2y. Let's take a y times 2 minus what? 2 raised to power 3 equals 0. Then this one becomes y squared plus 2y, then minus 8 equals 0. This 2 raised to power 3 can back to what? To that 8 back. So this is now what? An exponential equation. Let's look for y. How do you look for y? You look for a factor that will multiply each one that will give us 8. And it's the same number that will next each other that will give us 8. And either way we add it or we subtract it that will give us what? Plus 2. So that was the number. So let's say if 8 times 1 to give us 8, if you say 8 plus 1, and never goes plus 2. So let's say 4 times 2 give us what? 8. 4 times 2 give us 8. And you are looking for what? Minus 8. What if you say minus 4 times what? Times 2 to give us what? Minus 4 times 2 to give us what? Minus 8. But if you say minus 4 plus 2 to give us what? Minus 2. So it is wrong. So you can say 4 times minus 2 minus 8. Then when we say 4 minus 2, that's what? 2. So we are using this. We are using 4 and minus 2. So we say y squared plus 4y. We are using 4 and minus 2 because when we times it, 4 times minus 2 give us minus 8. Then 4 minus 2 will give us what? 2. So for y squared plus 4y, then what? Minus 2y, then minus 8, then equals 0. So at this point now, we can now split by saying this and what? This. We differentiate. So now, what's common? Y plus what? 4. Then what's common here? Minus 2. Minus 2 is common here. Minus 2y times that will give us minus 2y back. Then minus 2 times a, know that gives us minus 8 as what? 4. Then equals 0. See, minus 2 times 4 will give us minus 8. So now, y minus 2. Then y plus 4 equals 0. So at this point now, we say what? We split it into 2. Y minus 2 equals 0, comma, y plus 4 equals 0. So y equals to 2 and y equals to minus 4. At the second question. So now, at this point now, we stop. So in our next view now, we move to another topic that will talk about, let's say, standard form or logarithm. It's still based on what? Indices. We use indices in standard form. We also use indices in what? In logarithm. So in our next concept now, we talk about standard form and logarithm. Thank you very much for following me. Thank you very much for viewing this. So in our next part now, we continue. Please subscribe.